Hello, welcome back to Learn Physics. In today's topic, we are discussing about gravitation chapter, that is a quick revision of this gravitation chapter for class 9. Actually for class 11 students also gravitation chapter is there, but that is a little bit higher level. Okay, so here there's basic levels of gravitation we are studying here, and this is already explained the theory portions in detail we explained in the previous videos, and today it's a quick revision for your exam purpose. Okay, so here gravitation. So first we learned about this Newton's law of gravitation. So what is Newton's law of gravitation? Newton's law of gravitation or universal law of gravitation or universal law of gravitation. What is universal law of gravitation? Universal law of gravitation states that if two objects having masses m1 and m2 are separated with a distance r, then force acting between these two objects is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay, so the universal law of gravitation states that force acting between two objects, between the objects only we are telling about the gravitational force. Okay, usually gravitation means we always relate it with the earth's force of attraction, like that. Here universal law of gravitation states that for the two objects which are having masses m1 and m2 are separated by a distance r, then force acting between the objects is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. That is, F equals G into m1 m2 divided by r square. G is called a universal gravitational constant. Its value is G equals 6.673 into 10 to the power minus 11 Newton meter square per kilogram square. This value was given by the scientist Cavendish. Cavendish only experimentally determined the value of this G, that is 6.673 into 10 to the power minus 11. Unit is Newton into meter square divided by kilogram square. Okay, this is about universal law of gravitation. So this gravitational force, it's a weak force. Okay, gravitational force is a weak force, and it involves the mass, okay, and distance between the masses. Okay, so as mass increases, here if mass is increasing, force also will increase, gravitational forces increase. Okay, m1 or m2, if any one of these forces increase, any one of these masses increases also, or both the masses increases, force will increase. As r increases, since it is in the denominator, F will decrease. Okay, clear? So this is about the universal law of gravitation. Okay, clear? So next is, what are the importance of universal law of gravitation? Law of gravitation. Okay, so importance of Newton's law of gravitation or universal law of gravitation is the force that binds us to the earth. So we are bounding to the earth with the help of this universal law of gravitation, because force is acting between us and earth. Okay, so force that binds us to the earth. Okay, that is the first importance. Second one, motion of the planets around the sun. Motion of planet around the sun. Then motion of earth or motion of the star or this universe, all the celestial objects, that is motion of moon around the earth, motion of moon around the earth. Okay, these are the importance of law of gravitation. This can be asked as a 1 mark or 2 mark question. So force that binds us to the earth and motion of moon around the earth, and the planets, all the planets are revolving around the earth, right? That also due to this universal law of gravitation. We can explain that with the help of this universal law of gravitation. Next is free fall. What is meant by free fall? If the object is falling down only with the help of gravity, okay, if the object is falling down only with the help of gravity, then we can say it is under free fall. Okay, so the force acting on this object will be F is equal to mass into acceleration. Here the acceleration will be the acceleration due to gravity because of earth. Okay, so acceleration due to gravity, that is represented as small letter g. Okay, so g equals, so we can write it as force acting on that object will be mg. Okay, the free fall is the force acting, if an object is falling down, it is falling down with the help of Earth's gravity alone. Okay, it is falling down with the help of Earth's gravity alone. That is called a gravitational force or force of gravity. F is equal to mg. This only under the effect of gravity means it is called a free fall. In that case, the force acting is force into mass into acceleration. This is as per Newton's second law we learnt. A is equal to g, so therefore F is equal to mg. Now we are going to find out the value of g. How we can find out the value of g? See, I am considering the m mass of an object. This is capital M is the mass of Earth. Okay, the force of attraction between the object and the mass of Earth. How we can write down? As per Newton's law of gravitation or universal law of gravitation, F is equal to g m1 m2 divided by, what is the distance between the Earth and the object? Re, radius of Earth, right? So the distance between them is Re square. Okay, so we should consider till the center of this one, but while we are considering the radius of Earth is very much greater than the radius of object. So therefore we can write it as Re plus R is nearly equal to Re. Because if some 10,000 plus 1 centimeter, whether it will affect more? No, it won't affect, isn't it? So that is the reason GMME by RE square only we are considering. But under free fall, what we can consider? F is equal to mg. So left hand sides are F. So we can equate GMM divided by RE square equals mg. Therefore, G equals Gm divided by Re square. This is the value of acceleration due to gravity of Earth. Okay, acceleration due to gravity of Earth is Gm by Re square. Okay, so using this formula, we can find out the gravitation due to any planets, what is the acceleration due to gravity, we can find out. We know in moon the acceleration is acceleration due to gravity is very less. Okay, while we are calculating the gravity at moon, it is 1/10 of gravity of Earth. Okay, gravity in moon is equal to 1/10 of gravity of Earth. So in last one of the comments, one child asked me, if mass is reducing by 10, how the gravity will be affecting on Earth. So if mass of an object is 100 kilogram, and if it is, so if mass of an object is, his question was like this, if mass of an object is reducing to 10%, decreases to 10%. So how it will affect the gravity? Because G equals Gm by Ra square. Okay, if this mass is reducing by 10% means here gravity also reduce, isn't it? But if distance between the object is reduced means that much it will increase. Okay, since it is the denominator, it is inversely proportional. Okay, here mass which is in the numerator which is increasing, therefore gravity will increase. If the gravity, this 10% is decreasing, gravity will decrease. If it is increasing, gravity will increase. Okay, which are in the numerator, which is increasing, will increase the left hand side, which are in the denominator, will decrease at the left side. Okay, denominator increasing means left side increase. Inversely proportional. If this is increasing, gravity will decrease. If numerator is increasing, gravity will increase. Clear, I guess? Okay. Numerator increases, left hand side will increase. Denominator increase, left side will decrease. Okay. Clear? Now, the value of G. Value of G is 9.8 meter per second square. Okay, then next we are going to calculate equations of motion. Equations of motion when we are considering about the earth. Okay, so we know that V is equal to U plus AT. Okay, if the object is under free fall, how this will be changing? U will be equal to 0, A will be equal to G. Then V is equal to G into T. Free fall. Free fall means object is falling down, dropping the object. In that way it will come. So initial velocity is equal to 0. Then we know S is equal to ut plus half at square. This one how it will be changing? Under free fall, u is equal to 0, a is equal to g. Therefore, S is equal to half gt square. Okay, next V square minus U square equals 2AS. How it will be changing? V square equals 2GS. Okay, these are the equations of motion in the case of free fall. Free fall, you can remember U. Initial velocity is equal to 0 and acceleration is equal to G. Okay, so the next one is, what is the difference between mass and weight? Mass is the quantity of matter contained in an object. Mass is the quantity of matter contained in an object. Its unit is kilogram. Unit of mass is kilogram. Weight is the force that gives by earth to the object. Force that gives by the earth to the object is weight. It is weight is considered as the force that earth is giving to the object. So it will be, unit will be Newton. Force, unit of force we will be giving. Weight we can calculate using the formula mg. Okay, so weight, so as we said in the previous case, if mass is reducing by 10%, weight also will be reducing by 10%. So that and all you should relate. Okay, so that is mass and weight. So next we are going to study about the thrust and pressure. Okay, so what is this thrust? Thrust and pressure. Thrust is the perpendicular force acting on an object. Okay, thrust is the perpendicular force acting on an object is called a thrust. The force which is acting perpendicular to the object. Perpendicular means 90 degree. The force which is acting perpendicular to an object to the particular surface, that is called a thrust. Perpendicular force. Okay, then what is pressure? Pressure is the force or thrust acting per unit area. This is called a pressure. Okay, pressure is the thrust acting per unit area. Its unit will be Newton per meter square. Thrust is unit as it is the perpendicular force. So thrust unit is Newton, and Newton per meter square will be the unit of pressure. Okay, clear? So thrust acting per unit area is called a pressure. So relating to that, if see, while we are using a sharp end blade or a blunt blade, which will be more effective? Yes, sharp end will be more effective, because sharp means area is decreasing, then pressure will increase. In the same way, if we are using a heeled sandals or a flat sandals, which will be more comfortable? Flat sandal will be more comfortable, because in flat sandal area is more. Flat means area is more, then pressure acting on us will be, on the feet will be less. Okay, so and so as area increases, pressure will decrease. As area decreases, pressure will increase. Denominator decreases, left hand side will be increasing. Okay, so this one clear, right? This and all detailed explanation I already given in the previous topics. Okay, so next is Pascal's law. What is Pascal's law? The pressure acting at a point will be equally distributed to all the points. That is Pascal's law. Pressure acting at a single point will be equally distributing to all the points. That is Pascal's law. Okay, so the next is buoyancy. What is buoyant force? Buoyant force is the upward force acting on the object, on the fluid. Upward force acting on the fluid is called a buoyant force. Buoyant force is the upward force which is acting by the fluid is called as buoyant force. This buoyant force depends on density of the object or fluid. Density of the fluid. Buoyant force depends on the density. Density you know, right? Density equals mass by volume. Okay, buoyant force is the upward force acting by on the fluid. That is the force exerted by the fluid in the upward direction. So we know if we are trying to keep a ball inside a bucket of water, what will happen? Upward force will be the force, the ball will come up. Isn't it? What is the reason? Because it is due to the upward force. So the upward force given by the fluid in an object is called a buoyant force. Okay, it depends on the density of the fluid. Okay, so the next one is Archimedes principle. Archimedes principle. So what is Archimedes principle? See, Archimedes principle states that if an object is fully or partially immersed in a fluid, then it will experience an upward force. It will experience an upward force. That force will be equal to the weight of fluid displaced. Okay, if an object is partially or fully immersed in a fluid, the upward force which is acting on the fluid, the object will be equal to the weight of fluid displaced. When we are pushing it downwards, fluid will displace, isn't it? So weight of fluid displaced. See, if it is this much, before that if it is this much, now it is displaced this much, weight of F will be equal to weight of fluid displaced. Okay, which is equal to the upward force. This is the Archimedes principle. It is very, very important. Not only this one, all the name laws are very important. Okay, so if an object is partially or fully immersed in a fluid, then the weight of fluid displaced will be equal to the upward force. Okay, clear? So next is relative density. What is meant by relative density? Relative density is the density of a substance to the density of water. Okay, relative density is the relative density of substance to the density of water, that is relative density. It is not having any unit, no unit, because density by density, right? So it has no unit. And one more thing, it is important over here, when the fluid will be, when the object will be float or when the object will sink. Okay, if density of the object is less, density is less, density of object is less, it will float. If density is more, density of object is more, density of object is more, then it will sink. If density of an object is less, it will float. Less means less than the fluid which is immersed. So density of object is less than that of the fluid which is immersed in that. So then the object will float. Any one you can remember. If density of object is less than the fluid, then less than the density of the fluid, then it will float. Okay, so the other one is just opposite, like that you can remember. Okay, so these are the important concepts in this chapter. So relating to that, important questions we will be, and there's numericals also we will be discussing in the next videos. Okay, so I hope it is clear for you, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.